Good evening, students. Welcome to our learning channel. So, in the last video, under the topic called operations on matrices, I have covered how sum of two matrices, how to add two or more matrices, what is the condition to add two matrices, and next one I covered how to find the product of two matrices and the condition for multiplying two matrices. I gave one method called RC method, row into column transpose method, to get the each entry of the product. So in continuation of that topic, so we are going to cover the next one, subtraction. Then we call difference difference of matrices. This is a correct word we are going to use, difference of matrices. As I told you in the beginning, subtraction is a part of addition. So if you want to compute, if I want to compute A minus B, or difference between A and B, where A is one matrix, B is one matrix of same size. Here also same thing, matrices of same size. Condition, matrices of same size. If you want to take difference, this we will write, because I told you subtraction is a part of addition. We will write A plus. You already know how to add two matrices. I took plus there, some symbol. Here we take negative of B. This is called additive inverse. Additive inverse of B. In some books they write short form negative of B, or product of, product means multiplication, product of minus 1 and B. This, and first we have to find out additive inverse of B, or it is called negative of B, or product of minus 1 and B. In other context, this last one is called scalar product. Is also called as scalar product. Scalar product. Why is scalar product? Scalar means any real number. Scalar product of B, because we are multiplying the scalar number to B. Minus 1 is scalar. B is a matrix. It is called scalar product of B. It is scalar. Scalar. So these things you should be very careful with respect to the third operation on matrices, subtraction of matrices or difference of matrices, A minus B. We should write actually A plus negative B or additive inverse of B. The condition is that matrices of same size, just like addition, because we're doing addition here. Same. The condition to add two matrices is that the size of the two matrices must be same number of rows and columns. If they are different, just like how addition is not defined, this is also not defined. Both are correlated like that. So this is a simple example to understand that subtraction of two matrices. I have taken two matrices, capital A of size 2 by 4 and capital B of size 2 by 4. As I told you, the size of the matrix should be same, just like addition. So first, what you must do in this case, before going to that difference of A and B or B and A, first find negative of B, as I wrote in the previous explanation. Negative of B is also called additive inverse of B. Additive inverse. This word is most important. This one is preferred. How to find this one? It is minus 1 into B, or simply you can write minus B. Both are same. So what do you get here? Just you have to multiply the elements of matrix B with minus 1. Minus 1 into the scalar product. I will copy the matrix here. Now just compute. Negative 1 into 1, negative 1. Negative 1 into 4, negative 4. Negative 1 into 2, negative 2. Negative 1 into 9, negative 9. Come to next row. Negative 1 into 0 is 0. It is negative 6, negative 4, negative 2. This is your additive inverse of B. In second stage, you have to compute A minus B because we took additive inverse for B. So it should be second. It should be on second side or right side of B. So that is equal to part of addition I told you. It is A plus negative of B. Negative of B. Now you know how to get the sum. A 3 1 0 4 plus, and this matrix just now we computed 0 negative 6. So I'm going to write down that difference of two matrices. I will wipe off this. Now carefully you have to add addition, corresponding elements you have to add. 1 plus negative 1, 0. Negative 2 plus negative 4, negative 6. 4 plus negative 2, it is 2. 1 plus negative 9, it is negative 8. Next row. 3 plus 0, it is 3. 1 plus negative 6, negative 5. 0 plus negative 4, negative 4. 4 plus negative 2, it is 2. This is your required difference of A and B. If they ask you to find B minus A, B plus negative of A, same procedure you need to follow. Let us continue. The fourth operation on matrices, division operation on matrices. It is also called as quotient of matrices. Quotient, division. Just like I told you, difference of matrices or subtraction of matrices. So this generally we won't use the word division or quotient, but how to find out this? Is there any special condition for that? For addition and subtraction, order or the size of the two matrices must be same. Here also, first let you take any matrix, A, B, any matrix. Any instance, matrix may be rectangular or square. Either a square matrix or a rectangular. And the second one, matrix B, must be square. Be careful. Must be a square matrix. I write here non-zero. Means null matrices are not to be considered. Just like division by 0 in number system is not defined. 1 by 0, not defined. 2 by 0, not defined. My negative 5 by 0, not defined. Here null matrix should not be considered under division. Same ideology. In number system, how you are going to correlate. Here, there 0, here null matrix. Play the same role. Okay. So A can be either rectangular or square matrix. No condition on A. You see the second matrix. B must be a square matrix. It may be of size 2, size 3, size 4. It depends. Square. Same number of rows and same number of columns. Now, when you use the word division, we write like this. Or we can write like this. But here, in our matrices, we prefer this is not to be followed under matrices. In reality, we should write like this, but to differentiate from number system and algebra, we are not going to show the quotient. This is called quotient. If you show in a fraction form, it is called a quotient. If you show like this, division form. In matrices, we are going to prefer like this. A, this one, you can multiply either right side, we write it is b power negative 1. Depends on the size of the matrix. It may be like this, or you can multiply left of A or before A, b power minus 1 into A. This one, A by B, this one, we have to take to numerator. Division is a part of multiplication. Here division, here dot, multiplication. You know how to multiply two matrices I gave you. The number of columns of first matrix must be equal to number of rows of this matrix. Similarly, if you want to prefer this one, number of columns of first matrix must be equal to number of rows of second matrix. The product rule already explained in previous video. This one, whatever you wrote, is called inverse of B. Inverse, just inverse. INVERSE. Inverse of B. Because inverse of B under multiplication is possible only for square matrices. There it is additive inverse. Their orders may be anything, either rectangular or square, but in multiplication, we write b power negative 1. Which one to prefer, this one or this one? Both may be different. It depends on the size of the matrix A, which is on top, to which you are going to multiply. So, inverse of B, or we can write, it is called multiplicative inverse. Multiplicative inverse of B, of the matrix B. In short, we write this one, inverse of B. There, additive inverse, here, multiplicative inverse of B. To find inverse of B, this one B power minus 1, whatever I showed here, we have to know some requirements. Directly you can't compute B inverse. Directly you can't compute a B inverse. For that, in next video, I am going to explain what are the requirements to compute inverse of a square matrix. For that, you should know in advance what is minor, what is cofactor, what is determinant, what is adjoint of a matrix. If these four things are ready, then you can able to compute inverse. So first, in that order, we are going to see determinant of the square matrix, how to find. That is a crucial role will be played to find multiplicative inverse of D. So with this, I would like to conclude this video. So do share, subscribe and like our videos, and share it to your friends, your relatives also, those who are learning, so that they will get complete concept ideas to tackle the problems when they are going to encounter in matrices. All the best. God bless you all.